Good morning everyone, welcome to series 2 of my video. But before you watch, like, comment and subscribe. What are we dealing with this morning? Welcome to my physics 101 classroom. We'll be talking about principle of what? Of conservation of linear momentum. What do we understand by linear momentum? What some of you just understand is that what momentum is the what? Is the product of what? Of mass and velocity. But we have it what? How it's been conceived. Maybe we are talking about what? Each respective collision, either in inelastic or what? Elastic collision. So the principle of what? Conservation of momentum states that what? Before the moment the sum of momentum after collision is equal to what? The sum of momentum before collision, meaning that what? The momentum before collision is equal to what? The momentum after collision. That is just what? That is just the principle of what? Conservation of what? Of linear momentum. So based on this principle of conservation of linear momentum, is not the one that makes us to have what? Two types of collision. When we are talking about the two types of collision, we have what? The elastic collision, and the what? Inelastic collision. I'll be explaining these two types of collision now. When we are trying to talk about the elastic collision, I want you to know that what? In elastic collision, both your what? Kinetic energy and momentum is concerned. Because immediately after collision, the two bodies is going to separate. Let's take for an example now. A car is coming from Ojo and another one is coming from what? From Songo. If they are to establish an elastic collision, immediately they collide. They are going to separate. That means that was no particular heat is lost in form of a kinetic energy. So in that particular case, both your momentum and kinetic energy is what? Is conserved. That is your elastic collision. But in inelastic collision, immediately they collide, they stick together. That is the inelastic collision. Meaning that what? In inelastic collision, only momentum is conserved. Your kinetic energy is not conserved. So we can summarize like this, right? In my elastic collision, kinetic energy and momentum is what? Is conserved. Then this one we cannot say that only momentum is what? Only momentum is what? Is conserved. Is conserved. We now have specific formulas that we use to calculate. Maybe they are what? When we are talking about the elastic collision, they conserve kinetic energy and they conserve momentum. Same thing as what? In elastic collision, they conserve what? Momentum. But note, in inelastic collision, your kinetic energy is equal to 0 because they are not what? They are not conserved. So let's start with the elastic collision. Discussing about the elastic collision, we have momentum conserved. We all know that our momentum is the product of mass and velocity. So automatically, if you have the two bodies, then we will now see that what? Momentum conserved now m1 u1 plus m2 u2 is equal to what? Is equal to m1 v1 plus what? Plus m2 v2, meaning that what? Their initial velocity is equal to what? Their final velocity. Am I? So this is the what? Initial momentum. This is initial momentum of the two body. Initial momentum of what? Initial momentum equals to final momentum. Final momentum. Meaning that what? This one, they have the initial momentum before they collide. And immediately after they collide, they have this. This is what? This is elastic collision. Just use the logical example I used. When two cars are coming, once they collide, they separate. That's elastic. But immediately they collide, they be with each other, they stick to each other. That's what's inelastic. In inelastic, object sticks. In what? Elastic, objects will separate. So this is just about our momentum concept in elastic collision. But in elastic collision again, we also have what? Kinetic energy being conceived. Right? That means that no heat is lost in what? In elastic collision. So we can say kinetic energy concept. Kinetic energy what? Energy concept we just know what? Half mv half mu square, half m1 u square, u1 square, plus what? Plus half m2 u2 square will now be equals to what? Half m1 v1 square plus what? Half m2 v2 or v2 square, meaning that what, where your u and v are what final, where your u and v are the initial and final velocity respectively. So please take note, in elastic collision, both momentum and kinetic energy are conserved, but in an inelastic collision, only your momentum is conserved, kinetic energy is not conserved. So now let's go back to our inelastic collisions. When we're talking about our inelastic collision, then for momentum that is conserved in my inelastic collision, momentum conserved, then I can say that I have my m1 u1 plus m2 plus m2 u2 is equals to what? M1 plus m2 into bracket v. Meaning that what, immediately they collide, they share what? One common velocity, which is this final velocity. It's not like the two body is going to have what? Final velocity. No, they share one final velocity. So that's so we have what? This first mass, this mass for body 1, this was initial velocity of the first mass, then this is what the mass of body 2, then the initial velocity of body 2. Am I communicating? But in my inelastic collision, kinetic energy is not conserved. So this is also the diagrammatic expression I'm trying to explain as well. When we have something like this, when we have a particular ball like this, that once they collide, once they collide, this is a typical inelastic collision. Inelastic collision. But in elastic collision, once they collide, there is still a typical space like the separate. So this is the typical elastic collision. Elastic collision. So the essence of this video is for you to understand the respective formulas to use in elastic collisions and inelastic collision, and sum it up. In elastic collision, both momentum and kinetic energy are conserved, but in inelastic collision, only momentum is conserved. So thank you very much for watching. Please like, comment and subscribe. You can also share it to your friends. Welcome back. You will still see me for series 3 of this video. Thank you very much.